Okay, hello everyone. This is Michael from Brevis. I'm a co-founder and CEO of Brevis. At Brevis, what we're building is something called the infinite compute layer for Web3 and everything. So what it is a smart, verifiable computing engine that enables you to build new kind of applications in blockchain, in AI, and even in Web2 that were not possible before. So before I dive into what exactly do we do, we just want to kind of first outline the problem we're trying to solve here. Blockchains themselves are often marketed as world computers. But as computers go, they're crappy ones. It is extremely expensive to run, and it cannot run faster than even a single server that is available, off the market. However, if you look at all the decentralized exchanges today, until very recently, which is enabled by us, none of the DEXs have this very simple and very useful feature. Why is that? Well, it is not because they don't want to build it. It actually is because that, to build something like this, it will bankrupt you in gas fee. If you want to run this kind of a computation to just simply access users' historical trade and compute what is their trading volume in last month, it will just directly bankrupt you in gas fee, even on the cheapest layer 2 you have. Now, the fundamental reason for that is because we're using a very simple form of computation in blockchain consensus process. So for any kind of a blockchain, it is run on distributed consensus. What it means is that all the validators in the networks are trying to agree on some result of the computation, right? So let me take a very simple example with a 2-node blockchain here. So Alice here is trying to compute what is the result of this multiplication equation. And what she is trying to do here is trying to convince Bob, the other validator, that the result she computed is correct. Now, in our blockchains today, the only way to do this is by doing recomputation. So Bob is going to do the same kind of computation, spend the same kind of computation power and cost, and get the same result. And then it can reach consensus. So this kind of a paradigm where the recomputation is the only way to do verification is the fundamental reason why blockchains are expensive and slow today. Because the same kind of computation gets repeated by tens of thousands times, hundreds of thousands times, even millions of times in Ethereum, for example, in a repeated fashion. So how do we solve that? Well, we can solve that by introducing a new concept in computing called verifiable computing. So in verifiable computing, you have different roles for different people. So in this case, Alice here becomes something called a prover. So what the prover does is it computes the result of the computation, but also generates something in addition to the computation itself called zero-knowledge proof. So zero-knowledge proof is this mathematical magic that can use to send it to anyone and easily allow anyone to verify the result of the computation with extremely low cost and low latency. So the magic about the ZK proof is that, we actually effectively decouple the computation process itself from a verification. Now, there is a magical property about ZK proof that is, even if your original computation's complexity increases, the cost to verify the computation itself stays the same and it stays low. So this really opens doors to enable new kind of scalability in blockchain where you can have just one node or one entity does all the computation you want and whatever complex computation you want, and then send all the result to the entire blockchain so that they can easily verify the result with extremely low cost without doing any kind of repeated computation. So this is the core reason why, verifiable computation is important. Now, why is this important? Is because this kind of new paradigm is what Brevis is built on, and it can enable blockchain to achieve really infinite amount of scalability and build applications with Web2-like user experience. And it can also be used in AI and Web2 space, which I don't have to time to talk about today. So for blockchain, once Brevis is connected with the blockchain, what will happen? Well, on blockchain, you now have access to something that is different than the smart contract itself. you can actually start to offload very complex and data-heavy computation to Brevis. Brevis will do the computation, but also generate something called a ZK proof, and the ZK proof will be submitted back to the blockchain. So the smart contract themselves doesn't actually have to carry out any computation at all. Instead, they will just simply verify the proof with extremely low cost. So what I want to highlight here is that Brevis is not theoretical. The concept of verifiable computing is very useful and is actually widely adopted in our wide, kind of an ecosystem partner map. So we work with some of the biggest names in the DeFi and in the blockchain space, such as MetaMask, PancakeSwap, BC, OpenEden, Euro, MetaMask, USD, Euler, Linea, Uniswap, and so many others to enable them to build new kind of applications and new kind of features that were not possible before. So let me just go through several very recent examples. Very recently, we launched the Linea Ignition in collaboration with Linea, the blockchain, and also Etherex, Aave, Euler, and Turtle. What it is a holistic blockchain growth program where the user themselves can generate a ZK proof of their interaction with the blockchain itself, and then use that ZK proof to claim reward in an entirely transparent, secure, and trust-free and scalable way. So if you go to like Linea Ignition .brevis.network page, you can see that and experience the application yourself. So we're distributing about 1 billion Linea token in the 10 weeks, and and they will have like continued reward going after that. So we also work with MetaMask, which has like 100 million users, to support their MetaMask card reward program that enables you to essentially have a better yield on your transactions and depositing MetaMask card with ZK proof as well. So, another big category we support other than reward distribution and the chain growth is intelligent DeFi. So we talked about this kind of use case where you can enable dynamic fee based on historical user behavior on-chain and a historical market behavior on-chain. So we launched this with PancakeSwap. So this is something called PancakeSwap Infinity, where if you trade a lot on PancakeSwap or if you hold Cake token and you can generate a ZK proof for that, you will just get a discount when you're trading on PancakeSwap. So we will also work with many of the biggest stable token protocols to help them embed quickly into the entire DeFi ecosystem by running something called continuous protocol incentivization that allows them to incentivize the user to use and provide liquidity for the ways that intended to do. So all the previous examples are kind of a half on-chain, half off-chain, right? So what we are thinking is that in the future, most of the applications that business logic are actually going to entirely run in an off-chain environment. So we're building with one of the biggest perp DEX protocols right now to enable a ZK-powered perp DEX. So you can have like centralized exchange like user experience, but also have optimal privacy. So you don't have kind of this liquidity assassination problem that we see on perp DEX protocols today. So my prediction is that in 10 years, 99% of the blockchain application computing is going to happen off-chain, and it's going to happen in a verifiable way, verified by ZK proof and hopefully by Brevis. So, I talked about what is Brevis, but also just let me kind of quickly go through what's actually inside the magic box here. So the centerpiece of Brevis is something called a Pico ZK VM. So Pico ZK VM is a general purpose ZK VM that can prove really any software you write. It is extremely developer friendly in the sense that if you're developing any kind of a ZK application using Pico, you don't need to know anything about ZK. What you need is to just write some very high level languages such as Rust and Go, and then that program can be easily ZK proven. So Pico is extremely fast. We basically provide the world's fastest ZK VM on a single GPU that is publicly available today. And you can see this on something called ETH-proof, which is like a benchmark site. It's like an equivalent of layer 2 bit for ZK VMs that shows that, we are actually kind of performing as one of the best ZK VMs out there. So, just a quick alpha leak here. We are going to announce something very soon called Pickle Prism. So it is going to be the world fastest ZK VM that is running multi-server GPU with multi-server clustering GPU with the capability to prove Ethereum blocks in real time. So Pickle is fast, but it's not fast enough because it is very general. So fundamentally, there is a trade-off between generality and also performance. So what we do here is that we want to operate Brevis at this sweet spot where you have both performance and also you have the capability to program things. So this is where our Pickle modularity architecture really shines, where we treat the central VM as a glue, which can be used to plug in multiple different specialized coprocessors for different and commonly used application scenarios. So instead of just focusing on something called function level precompiles to optimize and accelerate specific functions, we enable something called application level coprocessors that enables you to accelerate entire application sector use cases in a very coherent way. So one thing I want to mention is that we have something called an on-chain data coprocessor, which allows you to generate ZK proof of arbitrary computation on any historical on-chain data, and then utilize the computation result directly in your smart contract. This is why we can have so many different partners that I showed you with so many different big names that is like actually using Brevis, because we can actually achieve and we can actually meet the performance requirement with this kind of a glue and coprocessor architecture in our ZK VM. So as I mentioned, you can get a further performance boost if you use this kind of a performance optimization technique that we're using. So on-chain data coprocessor is not the only thing we're building. We have ZK ML coprocessor, Lightline coprocessor, ZK TLI coprocessors that are all coming into our entire kind of a product and solution ecosystem. And as I mentioned, this is kind of precisely why we have so many kind of different use cases that is available and possible to be built on Brevis. So finally, we want the entire proof process and pipeline to be trust-free. And we have something called a Brevis Prover Net that is coming very soon to the market. So to sum up, Brevis is the infinite compute layer for Web3 and really kind of for anything. So I didn't have time to talk about a lot of other use cases for Brevis, but we're here to enable new design spaces, new applications, and a new level of scalability for the entire Web3 industry. Thank you.